Nice group here. Good evening, and thank you for coming to a moon conversation. I bet this is your first moon conversation. My name is Kate James, and I am the executive director here at Concord Art, as well as co-curator with Kathleen O'Hara of The Moon, Eternal Pearl. I'd like to take this opportunity to thank the Whitehead Foundation for making tonight's program and this exhibition possible. So, around 50 years ago, my father, who was a geologist, took me to see the moon rock in Atlantic City, New Jersey. Yeah, it's pretty amazing, right? It was a little bit like Catalyst Conversations, except he was the scientist and I was the artist. So, tonight's moderator, Deborah Davidson, is the founder and director of Catalyst Conversations. Deborah is an artist, a curator, and an educator, serving as gallery director at Suffolk University, and also she's on the faculty in the MFA program at Lesley University College of Art and Design. So please join me in welcoming Deborah Davidson.
Thank you very much. It's so great to be here and to see all of you and to be in the presence or the under the moon. This is one of our Catalyst to Go programs, and we're just really pleased to be here. It's also great to be in a space surrounded by the artwork. It's very inspiring, and it's a beautifully curated show. Catalyst Conversations was founded in late 2012 to open a critical path for dialogue between the arts and sciences. And we present intimate and provocative conversations between artists, scientists, and the public. And we're interested in connecting the two through programs, educational outreach, and events like this, which demonstrate the important conversation and synergy between art, science, and technology. And this evening's topic is Why the Moon? We Earth dwellers are always in relationship to the moon. In Sharon Harper's multiple exposure photographs from the series Moon Studies and Star Scratches, the camera maps a relationship between the movement of the Earth, the photographer, and the camera. These images are an attempt to record a realm we can hardly fathom, but within a framework of time we can readily understand, bringing the human scale into relationship with the cosmic. For Yaray, it is important to understand the formation of the moon, since the same formation scenario is likely to occur very, very often in early solar systems. The leading hypothesis, the giant impact, fulfills many physical constraints on the moon's size, angular momentum, and small lunar core. However, in terms of isotopes, there are a lot of unsolved problems to explain the similarity between the Earth and Moon, given that the latter is expected to have different isotopic composition from the Earth. Her research measures the isotopic composition of both Earth and Moon, and she is among a group of researchers who are looking at this isotopic issue, and some of the language that's used by the researchers is that the moon and Earth are twins, which I just find incredibly, poetic and beautiful. Just that the moon is our twin, so I think that might be one of the reasons we're so compelled. It seems many of us are compelled by the moon, and anyway, she will tell you more about that. They will each present for about 10 minutes their particular projects, and then we'll all sit down and discuss. They'll discuss with each other their respective fields, explore meaning from observation of phenomenon on and beyond the Earth, that is the moon, and how meaning is brought back to this sphere. Sharon Harper received her MFA in photography and related media from the School of Visual Arts in New York. Her work explores the intersection of technology and perception, which I love that pairing. It is in permanent collections at the Museum of Modern Art, the Whitney Museum of Fine Art Houston, the Albright Museum in Buffalo, Museum of Fine Art, and Harvard Art Museums. and the New York Public Library, among other collections. She has received and attended numerous artist residency fellowships, including Yaddo, McDowell, Headland Center for the Arts, UCross, Virginia Center for Creative Arts, and the Banff Center. She is a 2013 recipient of a Guggenheim in photography and is currently a professor of visual and environmental studies at Harvard. Yaray is a PhD candidate in the Department of Earth and Planetary Science at Harvard. She studied geology at the University in Taiwan and moved to the United States to study moon formation. Her studies focus on the geology of the moon and the analysis of the isotopic compositions of lunar rocks to understand the formation of the moon. She's very active as a volunteer at Harvard museums, such as I Heart Science and the coming celebration of the 50th anniversary of the 69 landing on the moon, which this exhibition also celebrates. She enjoys connecting her research to events, acting as a bridge between her specific knowledge and the public's curiosity, hopefully inspiring the next generation of young scientists. So with that, who's going to go first? Sharon. So, yeah, great. So Sharon, then Yaray, and then we'll come together to talk.
Thank you so much, Deborah, for bringing us together. It's really nice to be here with Yaray and you, and I look forward to this conversation, and thank you all for coming. I just want to thank Kate James and Kathleen O'Hara and everyone at the Concord Art Association for putting together such a beautiful exhibition. I hope you have time afterward to really take a close look. There's Kiki Smith downstairs and Stephen Dorado in this beautiful room. What I'm going to do in 10 minutes is talk about my process a little bit, and then we'll have conversation back and forth. So as an artist, as Deborah mentioned, I've worked at the intersection of technology and perception for about 20 years. I'm going to read a little bit here to make sure I stay in the 10-minute zone. And what I've been doing is using the camera to show about how we are invisibly networked within the living environment. I'm interested in how our intangible ties to the world around us, ties that many belief systems take as a matter of fact, can be revealed through photography. I think of photography as relational, which may be something that we don't often think of in terms of photography. The relationships that are embedded in photography are some of the subjects I'm exploring. So there's a relationship between the artist and the subject of a photograph. There's a relationship between the viewer of a photograph and the photograph itself. But for me, the camera and photography is also a technology that allows and has the potential for me to inscribe a record of our connection to place, even if the place is the cosmos. So I find that photography functions this way a lot like poetry. If you think about starting with a concrete, recognizable subject or words, and according to how you frame it or string it together, you're instantly transported into the world of networked ideas. Quite often, I'm working against my training and expectation of photography to broaden my understanding of it. My interest in photography and understanding of it in high school began as documentary. I used the evidentiary qualities of photography to verify conditions around me and to bear witness. I still have questions of social justice in mind, but I've grown interested in the ways that photography can be used to talk about existential concerns. So I'm going to start with this series of moon studies and star scratches, which this is also a piece from the same series as this piece. It was a series that was made from 2003 to 2009, so it's a pretty long period of time that I worked on it. The photographs build an experimental relationship between the camera, the image maker, and the natural world. Moons are photographed onto a single sheet of film over the course of days or months to generate each image. This photograph is one of the first images I made in this series, and it gives a good idea of why I started to photograph the way I did. This is an eclipse of the moon made in Greensboro, North Carolina. And when I saw the image, I could see that it recorded the phenomena of the eclipse, but it also recorded the movements of the camera and the photographer. I liked that it implicated the act of perception in the record of the image itself. I wanted to include a slide of my notes and the sort of data that I take down because it's interesting. It's a technical medium, and I am very concerned with techniques, but there's a kind of jazz or improvisation going on here. And the things that are really critical to me are how many full moons have I recorded? Has there been a full moon yet? How long are the exposures that I've been taking? Where are the locations that I've made these images? And all of those things end up in the title of the image. So I want to jump to this body of work from which this piece comes, called Sun Moon Trying to See Through a Telescope. We cannot look at the sun directly or know the details of the moon's surface without a mediating instrument. This project explores the impact cameras and optics have on an image and examines the limits of seeing. All of the images here are visibly impacted by the telescope in the camera. Visible distortions and reflections from inside the telescope appear within the image. Each attempt to capture and look at the physical object is frozen for scrutiny with a time-date stamp printed on the image. The time sequence and grids refer to the historic photographic motion studies made for scientific purposes. But here, however, the motion recorded is not of the object, but is turned back on that of the camera telescope in the process of perception. These sequences suggest understanding as a cumulative act in which the ideal of the moon and the sun remains elusive. What we're left with is the act of trying to see and trying to understand. I wanted to get at these ideas in various forms. This is very bright here. Let me see if I can, I don't know how well you can see that image. Oh, I just successfully got rid of my whole presenter. Okay, so we're freeforming now. So I wanted to do this in a variety of ways. So in this scroll, what this is this is the first time I went and photographed the sun. And I was very excited to have a telescope with a digital camera attached to it and went outside in the noonday. And I had a digital camera. If you've ever tried to look through your digital camera in the middle of the day, you know that that screen you're looking through is deceptive if you can even make anything out. But I was totally excited about this. I had the right filter so I wouldn't burn out my eyes. I went back to my studio and downloaded the images from it, and I realized that what I was looking at was not images of the sun. It was images of the light bouncing around inside this telescope in the mirror at the bottom of the telescope. There are a few images of the sun here, but I loved that there was no way for me to know, even with all the information available in that experiment and in that moment. So what I did is I made a cumulative view of this act of photographing and trying to see this. And then on the solstice, I photographed right at noon, just a triptych of the sun. So how much time? Do I have another couple of? Yeah. Okay, so my presenter went off, so I'm complete. I don't know what the time is. Okay, so I wanted to show you a couple of series that deal more with simply perceiving light. And this is a image of watching the sunrise over the Grand Canyon for an hour from 5 a.m. to 6 a.m. That's the title of it. And when I went to photograph at the Grand Canyon, I didn't know what to do because I had this indelible image in my mind of this iconic red rock body and wasn't sure what to do with it. But when I looked at the canyon itself, I realized it changed every minute, that it actually, the light is playing on it at every minute. So what I did was photograph for an hour and then take excerpts in chronological order and then showed that the light first coming into the camera is this bright yellow, and then it turns to this kind of copper and becomes what I find surprising, this very dusty, monochrome brown at the bottom, which is not how we think of the Grand Canyon. But one of the questions I'm dealing with a lot is, how do you try to reimagine a place that is so indelibly imagined? And in that vein, I was photographing at solstice in Norway at a very special time of the year in June, over the course of the brightest time of the year. And I knew that I wanted to do something out on this jetty that met with the sea. So I brought a pinhole camera and I put a sheet of transparency film. And every night over the course of solstice, I would take a sheet of film, open the aperture, and leave it open for the course of when the light was dimmest in the sky. So from like 11 p.m. to 4 in the morning. And so instead of measuring the night in terms of darkness, it was actually measuring the night in terms of light accumulation. So the differences on these sheets of film, the first night I photographed in black and white. I was afraid that nothing would show up I didn't know how dim it would be. And then for the next nights, I got a little curious what it might look like in color. And mind you, I don't see these films until I'm well back in the United States and can't redo. So I decided the next nights to try in color. And what we're seeing really is the variations and differences in the kinds of cloud cover and the ambient light in the sky. And one night over here with the specks on it, it rained. And actually what you see are the raindrops coming through the aperture and spraying onto the transparency film and fixing there, which I really love as much as the telescope, that I'm seeing the light and I'm seeing the material and the camera embedded in this record. And I'm always fascinated in photography how those things happen. I made a sister set of images at the winter solstice in Vermont. I wasn't able to go back to Norway. And the image on your right is also a pinhole image that was laid out in a field at sunset. And then I closed the shutter at sunrise, although that was at 5 in the evening and then at 7:30 in the morning. And interestingly, the moon ran across the top of it. But also it did snow and get crusty. And so there's all these crusts of little snows, which of course I love on that. And then the other image is a very traditional image of a 4x5 image of the night as it's falling right at the last light at 5 o'clock. I'm really fascinated with what happens, and I think what brought me to the moon was how do you photograph at the limits of photography? Like what happens at the limits of motion and a lack of light? So at the Norway residency for 3 weeks, at the end of the jetty, I would make a photograph of the sky, and then immediately below it, make a photograph of the water. And this was at 11 o'clock at night as the light's leaving the sky. And then I reintroduced the images as a diptych. I wanted to think about the relationship of the sky and the sea, but I found that with photography, when you take a picture of both in the same image, you're locked into this relationship of a seascape or a landscape. And it doesn't really make me in any way think about those two entities materially or in terms of atmosphere or in terms of their relationship. So I made these diptychs of the images as they're at the edge of what's possible to photograph. And that's it, actually. So I will turn it over to Yaray.
Okay, so for the next 10 minutes, let's talk about science. But you don't have to worry, you just have to focus for 10 minutes. Yeah, so today I'm going to talk about the formation of our moon specifically. So there are different scenarios that can form the moon. First of all, the moon can be formed in situ with their host planets. But that is not the case for our moon, because in this case, you will expect that the moon have the same composition, like the same size or the same ratio of the core and mantle. And the other case is like the moon can form by captured. But our moon is too big and also too rounded that there's just little chance that moon can be captured. So there's another leading hypothesis, it's called the giant impact. that the moon actually formed by a collision between the proto-Earth and also a proto-planet. And I'm going to talk about that. So early in the solar system, there is a Mars-sized planet called Theia that collided with the proto-Earth. And then the collision made a lot of debris ejected to the around the Earth, and those ejecta orbit around the Earth and eventually collapse gravitationally to form the moon. So based on this, the giant impact hypothesis model, most of the moon material were coming from the impactor, around like 80%. So the differences in terms of the chemical or isotopes between moon and Earth are expected because they are literally from the different material. However, that is not the case that we see. So the moon and Earth surprisingly share a lot of similarities in terms of isotopes and chemical composition. So what is isotopes? Isotopes are the same elements, but they have different mass. Just like the two pictures, they're the same person, but they look different. They have different weight. So you can see how hard I try to make science connected to the arts by, by putting the masterpieces. Yeah, so the differences in mass will cause the isotope or the element unevenly distributed in the solar system. That's why the different planets will have their own fingerprint, the different isotopic composition. So for the following talks, I'll be showing a lot of the isotope plotting, but that's pretty easy. So the isotope composition in terms of similarities or differences are denoted in delta notation on your lower left. So the delta notation means this is the ratio of O18 over O16 of the sample in respect to a standard in parts per mil. So in terms of thinking of isotope composition, it's always come with comparison. So the larger the delta notation, the larger the delta value means heavier. On the other side, vice versa means lighter. So let's go back to this figure. X-axis is the delta O18 and Y is delta O17. It's pretty obvious that different planets have different ratio, but you probably already noticed that the moon perfectly on top, lies on top of the terrestrial fractionation line, which means the moon and Earth actually have identical oxygen isotope. That is really, really rare. As I said, the isotope means the genetic fingerprint or genetic fingerprint of each planetary body. Not single planetary system in the solar system share the same isotopic composition, but our moon and Earth do. That's pretty cool. So it turns out like not only oxygens, but there's so many elements also show similarities between Earth and the moon. So on your left-hand side, I plot, but my group plots different elements in the x-axis, and then the y-axis is the moon reservoir normalized to bauxite Earth. So when the ratio or the value equal to 1, which means the moon and the Earth have the same abundance. Here you can see in terms of aluminum, calcium, titanium, and other major elements, the moon and Earth are literally identical. And on your right-hand side is the titanium isotopes. So x-axis is the isotopic composition, and then the y-axis makes nothing but just to separate different samples. So you can say it's pretty undistinguishable between Earth and the moon. So many scientists have worked very hard to modify the classic giant impact model to make the moon and Earth actually coming from the same material. So let me just remind you again, the classic or the old giant impact model is saying that the moon is formed by a collision between a Mars-sized body and then the Earth. And after the impact, most of the moon material were coming from the impactor. So the yellow dot means represent the impactor, and then the green dots represent the Earth material. So some scientists said, oh, maybe we just make the make the proto-Earth or the Earth in the past to spin faster. So after the impact, that there much more Earth material get ejected to the orbit. So you can see out of this simulation that the moon, on your very right side, the moon-forming disk, the majority of the disk is actually green color, which means they're coming from Earth. Another thing is you can actually create a very, very violent impact that you just like smash two planets. And then after that impact, it actually forms a giant cloud that the moon eventually condenses out of that vapor. So the moon and the Earth are made up from the same material. That also solves the problem. Or you can have a post-impact homogenization, that the moon reservoir and then the Earth reservoir, after the impact, they just equilibriumly exchange material to erase any difference between the impactor and proto-Earth. So it seems like problem has been solved. So there's no point for me to keep doing my PhD program because it turns out like perfectly we know how moon formed. However, it turns out it's not the case. So we were very excited that moon and the Earth are twins, but I'm gonna be a very bad person say they're actually not identical twins. There's some difference between them. So it turns out that the moon is depleted in volatile elements, and it is also enriched in heavier isotope of these elements compared to the Earth. So on your left-hand side is the same plot, but instead of major elements, we plot the volatile elements: rubidium, potassium, sulfur, lead, and water. So y-axis, the same as the moon reservoir normalized to bauxitic Earth. So by definition, Earth is 1, and then you can see there, for the volatile elements, the moon is actually depleted. And on your right-hand side is the potassium isotope composition, that the moon is heavier than the Earth. So why does the moon is depleted in abundance and then also have heavier isotope composition? For you to understand that, there's a metaphor. Imagine like all of us are cooking a soup of rocks. Sounds very appetizing. Yeah, so like the temperature give the same elements, well, give elements the same energy, but the lighter isotope escape faster than the heavier one. Just like, yeah, I'm not gonna do metaphor on human. So anyway, when you're like cooking the rock, the longer you cook, the reservoir of your pot, the residue in your pot will be more enriched in heavier isotope because the lighter isotopes are gone. So what's left is heavier. That's how you actually fractionate isotope. So why it doesn't happen to oxygen, magnesium, or those isotopes that Earth and the moon share similarity before? Because volatile elements are sensitive to temperature, but non-volatile elements are not. So any temperature-sensitive process can only affect the volatile, but not the other group of elements. Therefore, a loss in fractionation during the post-impact process must be considered into any alternative moon formation model. So things are not that simple, and my PhD work that I'm currently doing is to analyze the composition of Earth and then the moon in terms of volatile elements to figure out how much they're different or if they ever undergone some temperature-sensitive process, and then to determine the pressure and temperature of the giant impact. So just to sum up, any successful moon formation model has to satisfy, first of all, the similarities in terms of non-volatile elements. And also it has to reproduce the magnitude of isotopic fractionation in volatile elements, like potassium isotope that the right-hand plot showed. Understanding the moon formation is really important for us to understand our solar system or even universe. Apparently, the impact event is really normal and common in the early solar system. So understand how our moon formed can help us understand how other moons formed in the solar system or beyond solar system. And also, the Earth has plate tectonic, has weathering, so we no longer have very old material. We don't have the rocks older than 4.2 billion years ago, but the moon didn't. So the moon actually preserved a chunk of very valuable geological rocks for us to understand and to analyze it in order to know the composition of our proto-Earth, or even the composition of many terrestrial planets in the inner solar system. And the moon is really important for us because it stabilizes the Earth's rotation. That's how it makes the Earth habitable. So Earth is so unique and special, but not the moon or Mars. So the moon and Mars or other planets, they don't have the liquid water to support life, but we're still interested in understanding them. So the Earth might not be a good analog for studying Mars or other planets, but the moon is. So studying the craters or other space weathering process on the moon help us have the good analog for studying Mars. Not to mention that we successfully sent human beings to the moon 50 years ago. So for the future astronauts, if they want to go to Mars or even further destination, I think they will need to go to the moon to get trained. Yeah, so the moon inspires like a lot of scientific works in the past, right now, or will be in the future, I believe. And I'm very happy to be here to share my scientific work and celebrate the 50-year anniversary of lunar landing with you. Thank you.
Well, I think we're going to start with maybe repeat the question of why the moon, which is the same question that was posed to all the artists in the exhibition. And if you have the catalog, each artist's answer to why the moon is near their work. But I also want to just share with the audience part of our conversation that we had a couple days ago. And I asked Yaray why the moon, and she said, because it's so romantic and beautiful. And I just love that you are motivated, like as artists are, or as humans are, about the moon itself, and that you express that kind of passion through like studying rocks, including you shared with us that you have tiny samples of the moon sent to you from NASA, and you study that. So, and just I'm kind of quoting from your statement. You're asking with this work, how are we connected to things we cannot reach, touch, or fully understand? So I just think both those things are really interesting, and I'm going to give you the mic to respond.
Well, I think Yaray has touched the moon, right? You get samples with gloves. Okay. There's a caveat. I just love the idea that photography is essential in the study of science, in that even today that we see a photograph of a black hole, and we were both just, Yaray whipped out her phone and tried to Google, I'm like, but was that light the photograph was capturing, or was it some electromechanical, was it radio, was it, and I don't know actually, but it's so magical to see that. And we know that these distant bodies have influence over us, and I think a lot of times when I'm trying to understand something like that, I tend to go toward anthropology and look at another culture where things that are invisible or that are more epistemological in nature are taken for granted. For instance, in Buddhism, they describe all the stages of death in terms of light and in terms of how the life cycle progresses. You can actually study that and prepare for your death. And there are all kinds of ways in which energetically we're connected that are taken for granted, and in many, many different cultures. And so those are the kinds of connections. I know that photography can be used to study things scientifically, but I really love that it also can open up ideas about webs of information.
Yeah, so for me, it's really just, I thought the moon is so pretty, and I want to know where it is coming from and how it is formed. And so, of course, geology or science is the best or the one way to look at it. And in other words, like, doing science can be very boring, and you got to choose an object that you're attached to. So studying the moon is really, I really enjoy that, just because a lot of time when I am very tired or exhausted from doing the experiments, but I just walk out the lab and then look at the sky and the moon is there shining. And just like, oh, I need to do more work. And just go back to that. But I mean, like, we need a lot of self-motivation to do, like, no matter art or science. And I think the moon is my thing, yeah.
Is your what?
Is my thing. Like, I really, really like it.
It's your muse.
It's my muse, yes.
I love that you're talking about how your curiosity about it and how it's present in your life every day, that it really motivates you, because I think that's true of any endeavor that requires the amount of focus and the amount of attention that you give it, or that I gave it for 6 years, I guess, or longer actually, probably, because it probably took me a little while to get to where I was going. And I find the same thing is true, that you really have to invest in something that you love. And that if your basic curiosity isn't a driver through all the boredom and all the mundane aspects of the work, then it's really not going to carry you through. But one of the interesting things that maybe we haven't is that you're a geologist by training, and we sort of went like this because the work after I spent 12 years on the moon was I've been looking at the Earth and geology. So I wonder about that fascination about the rocks and the grounded in the earth, and also the connection to looking up and looking down. And I have nothing, profound to say about that, but I just find it a curiosity.
Yeah, I was going to actually bring up the same thing, that is, there's always, when I choose artists and scientists to talk to each other, there's a little bit of serendipity or intuition or something, on my part. And somehow I think that the two of you have this kind of, a lot of sort of synchronicity, but I didn't know that till we started, talking to each other. And I think, one of the reasons that you, like other moon scientists, are interested in the moon is that it's by looking at the rocks from the moon that we're also, you need to look at the Earth at the same time, or together. So.
Yeah, so the moon rocks actually looks pretty much like the Earth's rock. So they have like a dark side and a bright side. So the dark sides are basalts, just like when you go to Hawaii, you can just literally pick up the dark material from the ground. They're the same material. And then the bright side is anosite, which is like plagioclase accumulate of a certain white mineral. And that also occurred on Earth as well. So for me, it's like, for a lot of lunar scientists, they understand the moon by studying very hard about what is present on Earth. Just because we have samples, but just limited sample from the moon. So in order to fully understand the geology of the moon, we actually have to know the geological process that happened on the Earth and then apply to the moon. Mm-hmm. And then so, the other thing is like getting a piece of a rock from the moon is just so fascinating. By touching it, even though you're touching through your glove, but it's just like you're touching the sky. And I think that's really fascinating. It does make like touching the Earth rock and touching the moon rock totally feel differently. But now when I know the moon rocks actually are pretty similar to the Earth rock, I just appreciate Earth rock more.
Yeah, what you just described is making me think about the Origins of Life initiative that you're part of. Can you tell us about that?
Yes. Yes. So I'm involved or enrolled in a program called the Origins of Life Initiative at Harper. So basically, we're talking about the origins of life by definition. So there's a co-joint program between astrophysics department, Earth and Planetary department where I am, and also biology, chemistry department. So you might think to figure out the origins of life, we just stay in the lab and then just make RNA or DNA out of the experiments. But actually, to think this question in different way, which is actually required, you will need certain geological settings in the early Earth to provide or support those elements which make RNA and DNA. And also, like what planet is more likely to have life generated is is highly correlated to their astronomical property, like how far it should be. What the distance is the best from planets to their host star, or what is the perfect size and composition of the planets to have life. So like being enrolled in this program actually helped me have a different way of looking problem, and I think have a conversation with the experts from different areas, just have a lot of brainstorming, and which is really helpful.
So when you were telling us about all the similarities of the isotopes, I was like, you were the good guy then, and then you're like, I'm so sorry, I have to break the news that there are isotopes that are really different. So how recent is that in terms of, is that something that is being developed right now, that study and that idea that knowledge that the isotopes are different? Like, what's the time frame of that?
So the samples were brought back around 1917 era, and then they found the oxygen isotope around 2000 and 2005, maybe that 10 years, decade or so. But in order to tell the differences in terms of isotope, you will need a better or a good instrument to measure that. So we wouldn't be able to tell the difference until 2010 or 2015, and then by that time, when we have a better mass spectrometer, which is the instrument that we measure isotope, a lot of facts that in terms of volatile elements has been found that are different. So it's like 2015, I would say, but plus minus few years.
Yeah. Interesting.
Yeah, so not a lot of time. And we were talking earlier how, scientific or the information that we have at some point will be disputed or thrown out. And so, it seems like this is a very exciting moment to be studying the moon. So. And so, Sharon, I actually wanted to ask you about, so the subsequent work from the Moon series, you showed us some of those pieces of
Just light.
Just light,
more
yeah.
light.
Yeah. So that's a really interesting, I think, project for you as a photographer, that it's sort of like you're photographing sort of nothing.
That was, and I think that after working with the night sky for 12 years, and really I did get involved in questions about the moon because I was looking for what are the limits of photography, and I had this incredible experience of being in a residency at the Headland Center in California, where I go out and look at the ocean at night, and the waves would roll in and the moon was reflecting off it. Something I'd never seen before, I looked at that a lot, was that these very large waves would come in, and the minute that they would crest, the moon would fall off of them, and they were like this black, they were just a black gaping force, and it was really powerful to witness, and I'd never noticed that. I think on the East Coast the waves are smaller. I spent a lot of time in the ocean, but not, I hadn't really noticed that, and that impossibility of photographing that power, dealing with that power, I tried to capture it with black and white video and film and all kinds of things, but I think that pursuing something like that, so immaterial, I really was interested in just the light and what are the limits of light. And so while I was trying to get out of working with the night sky, which I really enjoyed those questions about the limits of photography and working in that space, I had a daughter. She was waking me up 3 times a night. I did not need to set my alarm to go out there and photograph the moon in addition to that. It was time to, and this happens with all kinds of projects, that there are reasons why you need to materially or otherwise conceptually move on. And I started to want to work in the day, but it's so descriptive. Photography can be very vernacular, and it can be a kind of window into reality. And I'm more interested in its qualities of forming networked ideas and ideas that are not necessarily having clarity to them. Although I love that kind of photography and I love how other people use it. So the opportunity to go to Norway at the White Nights was really great for me because it was a transition between night and light. And so it allowed me to start to work with just light and to figure out the problems of that and how to do that. And it was a beautiful kind of segue to working in the day, which turned out to be a lot of, it took me a long time to be able to find content that I wanted to work with in the day.
So, this is something that just sort of came to mind and maybe something that I think about, but it seems for both of you, in your respective practices, is there something humbling about, you know, photographing light or thinking about the moon, that there's something that, you know, you kind of aspire to, or it happens through the process to be trying to dealing with something that we can't understand really?
That's a great question. Do you want to, go ahead.
I don't think I really understand the moon yet, so it's the process still happening. So to answer this question in a different way, is like it does confuse me in the past that I think studying the moon, like nobody really cares. Like it is really cool, it's a fundamental science, but compared to like arts or the medical study that which benefit human being right away. Like you can see people get moved by photography, and also people like get cured by those medicine. But for me, like study geology is like really minor, and I got confused about that.
The grass is always greener.
Yeah, but I think like the moment that I changed my mind is when I was volunteering in the museum, that I saw little kids as well as adults. They are so curious about the moon rock. They're so curious about the universe. And then at that moment, I feel like actually what I'm doing might not be rewarding at this moment, but what I'm doing is actually build up the knowledge for the next generation, for them to have the resource to really push the knowledge to the age in the next generation. And then I think that helps a lot for me along my PhD program, because I just believe that.
I do find it really humbling, and I find that that is really like curiosity and love. It's one of those things that really brings me back to stand underneath the moon for, you know, a 4-hour exposure, or to sit there and go back again and again. I was making these images when I was in New York City, and I would go out to the far Rockaways or wake up and go to the Palisades when the moon was high enough in the sky to photograph, and just get myself out into this space where I could see enough and not get all of the remnants of the world in it. And I think that I do continually put myself into spaces that that put me in conversation with the place, because it dwarfs and seems to call out in some way.
Yeah, that's a good answer to a hard question. I think so. So I think we have a little time if the audience has anything to say or questions or. And John, how should we do this? Should we hand the mic around, or? Yeah, okay. Yeah. So we're only one mic this evening, so we all share.
Hi, thank you for your presentations tonight. I was wondering if you think that the moon, since its formation, has always been an inert celestial body, or if you think that at some point it might have had an atmosphere, a molten core, perhaps a magnetic field to protect it from exposure to the sun's celestial rays.
It's a question for me, right?
I think the idea of a more dynamic moon is very interesting.
Yeah.
You need this back.
Yeah, I guess. Yeah, this is a little clumsy, but okay.
So if I understand your question, you're saying the moon is actually pretty dynamic and...
I'm wondering if you believe it used to be dynamic.
Yeah, I totally do. So for just like I say, those dark material on the moon are basalt, just like what we observed on Hawaii. They're coming from the mantle. It's an eruption. So in the lunar history in the past, there must be an era or the period that the volcanism is very active. And then they also like analyze the lunar samples and they found the magnetic field residue in those rocks. So it's a question like when and how long the active moon has lasted, but it's totally a yes to your question.
Hi, another isotope question. Could other theories that you have difference in isotopes, they have different gravities, and there could be different percentages of capture of other space elements. Just a thought. The other thing is, what is the variability of isotope proportions even on Earth? Is the variance of what you found on the moon way beyond that which could be expected from just, you have very few samples from very few areas. Could the difference be just a statistical difference?
I guess we have a very scientific audience. To answer your first question about gravity, so some elements just will be affected by gravity. So say the neutron or the solar winds, they will have a certain isotopic ratio, and when it hit to the moon, the very surface of the moon will have anomaly for sure. But in order to determine the bulk composition of moon and the Earth, we actually correct for those effects. So the ratio that we get is we believe it represents the mantle. And then the other statistic question, for sure, yeah, we only have the near side samples. So it is possible that there might not be difference between Earth and the moon if we have more samples from the other parts. But for oxygen isotope, or for other isotopes, for other elements, it is important to sample different regions on Earth, say the subduction zone or the pure volcano, Hawaii, or a very old craton like in Canada. So if the different tectonic setting doesn't fractionate isotope, then we can say it probably wouldn't fractionate on the moon at different region as well. Because the same geological process should be universal in the universe. So if certain isotope doesn't vary, if certain isotopes they don't vary between different plate tectonic settings, then it should be also uniform on the moon.
Wow. Any other questions? Yeah.
Hi, thank you. So mine is an emotional question, and it's directed to both of you. So as you photograph the moon and as you study the moon, especially having moon rocks in your lab, what has been the emotional effect during the major lunar transits over the years? Have you felt any type of emotional effect when we have a dark moon and then we have a full moon?
Sharon will answer.
I can answer it first. And then
yeah, I always feel that the moon has an effect on me. I feel like it's personal to everybody how they reflect and respond to the moon, but I did find that being in close touch with it, which like knowing when it was rising every day and when it was setting, and that there are 7 days of the month that it doesn't rise and set during the night, and you know that it changes 45 minutes each day that it rises later by 45 minutes each day. Just being in touch with it in that way was really amazing, and it was grounding for me to be that aware of it.
For me, it's like really simple. If it's full moon, I'll be very happy. If there's no moon, I'll be very sad. But on the other hand, it's like if it's a full moon, and then I would just like go back to lab, keep working because full moon inspired me. And if there's like no moon, then I'll go home, which is good.
Hi, this is a question for Sharon, and it's coming from a scientist, so I'm sorry if it's a very basic one. But how does your experience, you and the photograph, and then the photograph and what you see at the end change when it's digital versus film in your exposure to light?
Oh, that's a great question. Because it's radically different. So when I was photographing the Moon Studies and Star Scratches series that I started talking about, those films I would not see for months at a time. So I was trying to imagine it like a drawing, and I had no idea where on the film the moons would be. There, you can see there are places where they overlap, or I would keep track of whether I had a full moon yet. This particular piece is part of their triptych of films that I was rotating around to try to stack the deck in favor of getting something actually. And I was really, really interested in that space of unknowing and allowing chance to be part of the process. And with digital photography, it's really, really hard, the descriptive power of it, for me to talk about things like perception and how do I photograph and work with material photographically that invites people in terms of trying to perceive a place or perceive something about it when it's so descriptive. So that's been very challenging for me. But so this was the first project I did that used a digital camera. I use digital cameras all the time in my life as diaristic and as we all are photographers. But this was the first time I used it in a project. And I think this idea of sequencing the images really helped me to talk about the ideas of expanding temporality and talking about the relationship between movement and time, kinds of motion studies. There's a time date stamp on it. Because it was digital, I could do that down to the 100th of a second. So I feel like they're all amazing, powerful tools, but they do function very differently. It's an excellent question.
I think we have time for one more.
Okay.
Hi. So the Chinese landed on the far side of the moon. Have we seen any data from that landing? Also, the Japanese have just been on an asteroid. They exploded a crater, moved the satellite to the other side of the asteroid, and are now bringing it back to the origin, the location of the asteroid, and they're going to send a drone down and check what the crater showed, which is supposed to go back to the origin of the universe. So we're going back into 4 or 5 billion years, and presumably the Chinese might have discovered something about differently from the front side versus the back side. And the other aspect is when the collision occurred, the other theory associated with that is that it was an ice ball which deposited sufficient amount of water into the earth. So the earth then carried water, which it may or probably didn't before. If it was hot, it would have evaporated like it did on Mars. And is there any presence of water on the moon's surface from the original rocks?
Okay.
Yeah, so the first part of your question, there are definitely some data from the far side, because not only the lander or the astronauts can bring back sample, we have the satellites orbiting around the moon. So we do a lot of like mineralogy mapping or some thermal property mapping as well to understand the full moon structure. And then the Japanese mission, which was really exciting because as you already know that analyzing sample is the best way to really go very deep to understand the scientific question. So bringing more samples from asteroid or the moon will be very promising, and in the future I think there will be more samples coming back, which is good, very good mission. And then for the big ice bowl or water bowl, like when, well, accreted with the Earth. So there are actually a lot of hypotheses saying that the Earth actually formed pretty dry, but there's like late veneer, or it's called late veneer because after the Earth was formed dry, there are some flux and a lot of impacting material from the outer solar system, which they're enriching water or volatile. They actually flew from the outer solar system to the inner solar system. So that material is potentially be a candidate to cause to make the Earth volatile enriched. So your point is valid. Is that all the questions? I think.
Thank you. I think that might be a good place to end this part of the conversation, and I want to thank you both for giving us a glimpse into your fascination with the moon, which has guided us humans since the beginning of human time, anyway. And thank you, everyone, for coming. If you're not familiar with Catalyst Conversations, you should look at our website, catalystconversations.org. We have started a podcast. We have some very interesting conversations that way, as well as the archive of all our programs that we've been doing for 7 years. So anyway, don't go away because we have a little reception, and our speakers are with us, and we can keep a larger conversation going. So thank you so much for coming.